So I kind of take this opportunity to welcome you all to my session on Wi-Fi 7. So the goal of my session is really twofold. Number one, to give you a solid understanding on what Wi-Fi 7 is all about and what are the benefits that it gets to your network. And number two, what does it take to adopt Wi-Fi 7 in your network and what are the current challenges? So I'll start off with a question on the current state of the spectrum and why do we need 6 gigahertz and why Wi-Fi 7? And once we get answered, we'll get into the what aspects of Wi-Fi 7. We will deep dive into the features that the Wi-Fi 7 offers and look into the benefit that kind of gets into your network. Thirdly, I'll spend a short time introducing the Cisco Wi-Fi 7 product portfolio and go over some of the key features that these access points offer. Finally, I'll spend some time on deployment and migration considerations that you need to be aware of if you want to adopt Wi-Fi 7 in your network. So why Wi-Fi 7? We all know that Wi-Fi has come a long way. It has had a stupendous growth in the last 25 years. There's been an exponential growth in the Wi-Fi devices. Wi-Fi has pretty much become the default medium of access. The speeds have increased multifold, and there is a great improvement in the SLA as well. And all these factors kind of fuel the modern application growth. And it's a catch-22 scenario wherein the very same application pushes the bar higher for network performance for its optimal performance. We have evolved from the primitive applications of the past, like simple file transfer, simple web browsing, voice over IP phones, and text-based emails, to the collaborative and richer applications of today, like this video conferencing applications, which is really bandwidth hungry, and all the way to the IoT applications and the AR, VR, XR applications, which are very stringent on SLA. And these applications expect an SLA of like low single digits as latency. And these AR, VR applications not something very far off in the future. It's all happening right in front of our eyes, and it's just a matter of time before it gets widely deployed in our campus. So the next question is, can we use this run these applications in the Wi-Fi infrastructure what we have today? So the answer to this question, in my opinion, is maybe. And the reason I'm being very skeptical is, number one, the channels are really congested, especially the 2.4 gigahertz spectrum. There are only 3 non-overlapping 20 megahertz channels, and we also share the spectrum with non-Wi-Fi devices. The channel utilization is so high that some of the customers with whom I work with, they have completely shut off the 2.4 gigahertz span to give the best user experience to their end users. If you look at the 5 gigahertz band, there are not that many channels if you discount all those radar channels. The ground and harsh reality is the spectrum is super stretched to the limits. And of course, the regulators realized this and added the 6 gigahertz spectrum space for unlicensed use of Wi-Fi. So it was about 5 years back or so, what we term as Wi-Fi 6E. And I'm pretty sure some of you probably have already adopted Wi-Fi 6E in your network. In this part of the world, at least we have 1200 megahertz of spectrum. It's a huge amount of spectrum that translates to 5920 megahertz channels, and it's going to be a huge impact to the Wi-Fi market. And the spectrum space is also relatively clean when you compare to the other unlicensed bands what we have for Wi-Fi. So 6 gigahertz spectrum kind of lays the foundation for the future growth of Wi-Fi. In fact, all the newer standards, this Wi-Fi 7 and the upcoming Wi-Fi 8, if you look at the kind of use cases they are trying to solve, it's all based on the underlying foundation that the 6 gigahertz spectrum is available, which is a huge amount of spectrum, and it's a clean spectrum for it to achieve the network performance that these applications needs. So what are the use cases that Wi-Fi 7 is trying to solve? Primarily based on these 3 network performance factors: high throughput, improved and deterministic latency, and third, greater reliability. If you look at all these applications like this high definition video conferencing, streaming, immersive learning, immersive gaming, AR, VR, XR, industrial IoT. They're all based on one or more of these network performance factors for their optimal performance. By the way, Wi-Fi 7 doesn't mandatorily need 6 gigahertz. It can run on 2.4 and 5 gigahertz. But if you have the 6 gigahertz band, if you have enabled 6 gigahertz, then it's going to help improve the network performance. So what is Wi-Fi 7? Wi-Fi 7, of course, is the 7th generation of Wi-Fi based on the IEEE 802.11be amendment termed as extremely high throughput. And IEEE 802.11be amendment as such, the work is complete. It's just pending the final publication, and it's expected any time. Wi-Fi Alliance, which is an independent body, picks up these technical specs from this IEEE amendments, adds the security component, adds the QoS components, and comes up with a feature list for a particular generation of Wi-Fi. For Wi-Fi 7, there are 2 releases planned. Release 1, the specs were already finalized January of last year, and for which the certification is in progress. Release 2, the specs is expected to be finalized by December of this year or early next year. And Release 2 is going to be a minor update, minor feature update. It's just going to be a software update. There's no hardware that is needed to have this R2 functionality. Cisco has been very closely involved in the development of these IEEE specs and the Wi-Fi 7 specs, and some of the best brains that you can think of in the industry, they all work on this IEEE committee and the Wi-Fi Alliance. And we also advocate thorough client interop testing. We work with several key client vendors and make sure we do a thorough interop test before the end users get this software and the drivers in their hands. We test their gadgets in our lab. They take our access points and test in their labs. We have regular cadence. We exchange notes on what works, what doesn't work, and we try to resolve as many issues as possible. Imagine if we do not do this kind of interop testing, it's going to be an absolute chaos. And Cisco is heavily invested in doing this interop testing so that the users get the best experience. So for today's discussion, for today's presentation, I'm going to restrict the discussions to Release 1 features. As I mentioned, Release 2 is a bit far off. It's end of this year or early next year, and the specs are getting finalized. And once the specs gets finalized, the access point vendors and the client vendors, they take some time to implement in their products. So next year Cisco Live will be the appropriate time to talk about those Release 2 features. When you look back at the previous Wi-Fi generations, the focus seemed to be kind of improving the speeds and the feeds, at least all the way till the 5th generation of Wi-Fi. 11N was termed as high throughput, 11AC was termed as very high throughput, and fast forward with Wi-Fi 6, which was based on 11AX, it was termed as high efficiency, and the focus kind of seemed to shift towards the efficiency aspects, especially with that OFDMA feature that Wi-Fi 6 introduced. But of course, there are some other features like 1K QAM that kind of increase the data rates that also contributed to the speeds and the feeds, but the focus was mainly on improving the efficiency. Fast forward with Wi-Fi 7, which is based on IEEE 802.11be, it's termed as extremely high throughput, and the focus seems to be again back on improving the speeds and feeds. Of course, there are features like 320 megahertz in the 6 gigahertz band, 4K QAM, MLO, they all contribute to the improvement in data rates and throughput. But Wi-Fi 7 is just not about only improving the speeds and feeds. There are features like preamble puncturing, multi-RU, compressed block hack. They all contribute to the efficiency aspects of Wi-Fi. There is Wi-Fi 7 also, there's a security component there. Wi-Fi 7 has up-leveled the security requirements. WPA3 is minimal and mandatory for certification and operation. There are new cipher requirements. There are new AKMs that's been added. Beacon protection is mandatory as well as for Wi-Fi 7. There's also a QoS component to improve and the latency mainly for some of the critical flows. Let's deep dive into the features that this Wi-Fi 7 offers. The very first one is the 320 megahertz channel width in 6 gigahertz. With Wi-Fi 6E, the maximum channel width was restricted to 160 megahertz. With Wi-Fi 7, it's doubled to 320 megahertz. So when you double the channel width, of course, it's going to help double the throughput, almost double. In this part of the world, we have this 1200 megahertz of spectrum that translates to 3 non-overlapping 320 megahertz channels if the access point is operating in low power indoor mode. If the access point is operating in the standard power mode, then we get 1 non-overlapping channel in US, and we get 2 non-overlapping channels in Canada. So it's kind of very difficult to arrive at a floor plan for the channel planning with all the access points operating in this 320 megahertz channel width, because it's definitely going to cause some co-channel interference. So this feature is kind of best suited for areas which is very controlled and well shielded, where the access points cannot see the neighbors, and the users in that area also are running some applications that really need very high throughput. Couple of, on the consumer side though, for whatever reason, they seem to have enabled this 320 megahertz channel width by default in those routers. I got my hands on a couple of routers, and it's going to be fine as long as your neighbor is going to be very far. If you're living in an apartment, or if your neighbor is going to be very close by, the scene is not going to be pretty. So you're not going to have a good Wi-Fi experience. Moving on, 4K QAM is an improved modulation when compared to the 1K QAM what we had in Wi-Fi 6 with 11AX. As you all know, QAM, or quadrature amplitude modulation, is a highly sophisticated modulation scheme to transmit data over radio frequencies in wireless communication. With 4K QAM, we get these 2 new MCS rates, MCS 12 and MCS 13. But for these radios to maintain such high modulation levels and give this high data rates, the SNR requirements are ridiculously high. We are looking at an SNR requirement of about 41 dB when compared to the 31 dB SNR requirement what we had with 11AX and Wi-Fi 6, and the 25 dB SNR requirement that what we had with the 256 QAM in 11AC with Wi-Fi 5. So the clients have to be really very close to the access points. We are looking at a distance of about 7 to 8 feet approximate distance, if at all, if you want to get these high data rates. So this is a feature that's something that's going to benefit a small number of users within a cell. It's not a widespread benefit that all the users in a given cell is going to benefit. 4K QAM and pushing this modulation higher is one of the ways to improve the data rates, and it has to happen. But is it a widespread benefit that you're going to get? No, absolutely not. But some users definitely within a cell are definitely going to get benefited. The next feature is MLO. In my opinion, this is the most coolest and the promising feature in Wi-Fi 7. When the Wi-Fi 7 specs were made available initially, when I was going through them, I was immediately convinced that this is going to be the most talked about feature in Wi-Fi 7. So I was very convinced, but I wanted to check with my friend who is very trustworthy and who is very knowledgeable. He has an answer for any topic that you may ask him. And then he also gives a very unbiased answer. So I thought of checking with my dear friend, Mr. ChatGPT. So I asked him, what do you think is the coolest feature in MLO? I mean, what is the coolest feature in a Wi-Fi 7? Without a wink, I got an answer back saying that MLO is the coolest feature, and was giving the justification. I tried to twist the question in many ways, and the answer was always consistent. MLO is a feature. Now that ChatGPT is convinced, there's no second thoughts there. MLO is indeed the important and promising feature of Wi-Fi 7. So what is MLO? MLO is where the wireless clients and the access points establish association links in multiple bands or multiple links and exchange data over this multiple bands. So it could be 5 and 6 gigahertz, or it could be 2.4 and a 5, or a 2.4 and a 6, or it could be all the 3 bands together. So because of this multi-link operation, obviously we get some benefits. The very first benefit that you're going to get is the throughput improvements because of the aggregation. Now the wireless clients and access point have more than one link to exchange data. So this aggregation is going to help improve the throughput. Applications like this high definition video conferencing is going to definitely benefit out of this aggregation method. The second one is the lower latency, improvements in the lower latency by dynamically steering the flows towards the link that the access points and the client think that they can achieve a better SLA. So applications like AR, VR, XR, and this industrial IoT applications, which are very stringent on SLA, they can benefit because of this lower latency. To begin with, maybe the flow is happening on the 6 gigahertz band. Maybe for some reason the channel is congested. So the clients and the access point can decide to steer this flow towards the 5 gigahertz band to achieve the SLA. The third one is the reliability aspects. Because of this multiple links that what we can have the redundancy. If one of the channel conditions are not good, the client and the AP can switch over the link to the other band. And the other possibility is the clients and access points can also send duplicate packets in multiple links. So if one of the link is congested or things are not great there and the packets have to be dropped, the duplicate packets from the other link can be used for processing. So,
is that configurable on the controller? Can you configure it to say, I want MLO only for redundancy for all clients?
So the question is, can I configure MLO on the controller? No, it's not configurable. You get all the benefits of MLO or not. And this MLO method is also, I'm going to go over the MLO method. That's again something client dependent. So once you enable the Wi-Fi 7, pretty much whatever the benefits that you're going to get out of MLO, you're going to get all of them. Moving on to because of this MLO functionality, the MAC layer is split into 2. There is a lower level MAC layer, that's a physical MAC layer, and then there's upper logical MAC layer. And there are specific functions associated to each of this MAC layer. Link specific operations like those beacon frames and control frames like RTS, CTS, acknowledgement, they're all tied to the lower MAC layer. And for the upper MAC layer, it's responsible for authentication, association, reassociation, encryption, decryption of unicast frames, and so on. So the reason for me to flash this slide here is that you need to know kind of the basics of that the MAC layer is split because of MLO functionality. And number 2, some of you might be looking at the Wireshark captures or maybe looking at the debug logs. So for troubleshooting scenarios, you need to know which MAC layer to look for the specific scenario that you are troubleshooting. And some of you also may be creating a policy in the AAA server for, like, say, MAC authentication, MAC filtering. So you need to know which MAC address to key in there. It's, of course, in this case, it's the upper MAC layer. There are many modes of MLO, and the reason being clients have different hardware capabilities. So the authors of this IEEE specs, when they wrote the specs, they all realized that it's going to be too much to implement some complex algorithm on the client side, and also it's too much to make the clients have multiple radios. So they defined multiple methods of MLO, and they left to the client vendors, and the client vendors are free to choose the method that they want to implement. At a high level, it's kind of classified into a single radio and a multi-radio. Single radio is where the clients have one single radio, but have the ability to form a multi-link association, multiple bands. And multi-radio is where the clients have more than one radio. In today's implementation, what you get in the market is mostly clients based off 2 radios. In the single radio method, the most simplest method is MLSR, multi-link single radio, wherein the clients just have one radio, but have the ability to form the multi-link association, multiple bands, but uses only one link to exchange data at any given point of time. And if for some reason the channel conditions are not good, it just switches over to the other link. EMLSR is an enhanced MLSR, wherein it's an MLSR plus the additional capability to listen to two links. It does so very smartly. It splits the radio chain and uses one of the radio chain to listen to one band, other radio chain to listen to other band. And if there is a transmit opportunity, it combines both the radio chains to send or receive the data. On the multi-radio, the first method is ML-MR-STR. It's multi-link, multi-radio, simultaneous transmit and receive, wherein the clients have more than one radio, and each radio acts independently to send and receive the data. There are also other methods defined like MLMR, NSTR, EMLMR, and so on. These are all defined in the IEEE 802.11be specs, but not enforced for the Wi-Fi certification. The reason being, the Wi-Fi Alliance felt that these algorithms are a bit complex and it's too much to implement on the client side. So the important methods to watch out are EMLSR and MLMR. And why I'm saying it's important to watch out, I'll walk you through the reasons as to why you have to pay attention to these methods. Here is an illustration of how EMLSR works. We have a wireless client that's a 2x2 radio chain with two spatial streams. For illustration purposes, I've taken the 5 gigahertz and the 6 gigahertz band, but it could be any combination. It could be 2.4 and a 5 or 2.4 and a 6. So to begin with, the client uses each of its radio chain to listen to different bands, the 5 gigahertz band and the 6 gigahertz band. So an AP wants to send some data down to the wireless client. To begin with, the medium is busy. And when it finds there is a transmit opportunity on the 5 gigahertz band, it's going to send an MU RTS frame. It's just nothing but an RTS frame with a multi-user info. And on receiving this frame, the client is going to send a CTS frame back. This is a very, very important step. Right after this, the client is going to switch both its radio chain to listen to the 5 gigahertz band to receive the data from the access point. It receives the data, and then it sends an acknowledgement back. After sending an acknowledgement back, it's going to split its radio chain, again going back to listening to both the bands. The next transmit opportunity could be in the 6 gigahertz band, and the same set of sequence continues. MLMR-STR, this is the multi-radio method, wherein the wireless clients have two radios, and each radio acts independently. They just send and receive data independently. And of course, you're going to get the best throughput and performance. And each method has its own pros and cons. The single radio method is a bit easy on the battery, but with the multi-radio, you're going to get the best throughput and performance. For Wi-Fi certification, they mandate that the access point has to implement MLSR, EMLSR on the single radio, and the MLMR-STR on the multi-radio. On the wireless client side, though, the Wi-Fi certification mandates MLSR for sure, and either EMLSR or MLMR, one of the methods. They need not implement all the three methods. We did some comparison tests. We do several tests of them. I just took one of these tests, and I want to flash the kind of benefit that you get with this MLO. We compared with the single link operation and a multi-link, with the client with Wi-Fi 7. So noticeably, there is a big improvement in throughput as when you push more traffic. With small amounts of traffic, there's no big difference. It's pretty much you get the same performance. And as you push more traffic, you see more, the best performance. And the latency also, there's a significant improvement in the latency. The latency, there's almost a 50% improvement in the latency when compared to the single link operation. So obviously, MLO, it gets you lots of benefits, will get you benefits, irrespective of any of the application, especially when the channels are, kind of getting congested. I've been front-ending this Wi-Fi 7 activities, I would say, for the past 8 to 10 months or so, be it the beta trials or talking to customers, partners, Cisco field specialists. And the one question, or if not three questions that I get consistently from the field is, number one, it's about MLO, directly related to the Wi-Fi 7 feature. on how things work there, or they share their observations and they want our inputs. The two other questions that I get is on Wi-Fi 7 security, because there's a lot of complexity that's happening in the security front. So questions related to that. And the third question that I get is about the power requirements to operate these access points. To be honest, I have not gotten a single question about any of the other features. I have not seen people asking me about the 4K QAM, 320 megahertz, MRU, and none of them. I've not seen any questions. But MLOs, I'm guaranteed in every week, at least I'll get 1 or 2 questions related to MLO. So there is a misconception that moment you turn on the MLO, somehow it's going to magically give 2x performance because there are 2 links, but the devil is in the detail. So from our observations, the EMLSR, the early drivers, they seem to have wanting the symmetric channel width. It has to be, if it's 80 megahertz, it has to be 80 megahertz on both. If it's an asymmetric channel width, then they seem to be pretty much doing an MLSR functionality. They were not doing an EMLSR functionality. But of course, the latest drivers have gotten a lot better. And with respect to MLMR, STR, most clients out there, they do 2.4 and a 5 or 2.4 and 6. So with this addition of 2.4, you get an incremental throughput benefit because of the 20 megahertz channel that you get from the 2.4 gigahertz band. However, I want to call out this chipset from Qualcomm, Fast Connect 7800 HPS, or they call it high band simultaneous, where they do this 5 and 6 or dual 5 gigahertz. You get the best performance with this chipset. And there's an example when I was trying to configure an HP OmniBook, and where they threw in this option, hey, do you want to use this chipset? So we have tried out pretty much the chipsets, and you can be assured that you're going to get the best throughput performance from this Qualcomm chipset. So from the throughput comparison, EMLSR and MLMR STR with the 2.4 and a 5 or 2.4 and 6 is going to get you some incremental throughput benefit, but the maximum benefit, it's almost about close to 2x the throughput when you compare with a single link is what you can get with this high band simultaneous clients. So the devil is in the detail. So when you try out this Wi-Fi 7 in your labs, and if you don't see the significant throughput improvement, look into the MLO method, what these clients are doing. And there's a demo that I thought I'll walk you through the behavior of these clients, what we call as load aware link utilization. We have a Wi-Fi 7 AP and the Wi-Fi 7 client, and this does an HPS that is 5 and 6 gigahertz. And we have an X-Chariot server that's pushing the traffic. Initially, we start out with small amount of traffic. You can see from the spectrum analyzer, even though it's a multi-link client, it uses only 1 link. The other link is not even employed. So after some time, we start pushing more traffic. We really keep pushing more traffic. At this point in time, the 6 gigahertz band is also utilized. It uses both the bands to kind of load share the traffic. So the observation, the conclusion is, even though it's an MLO client, when the traffic is really very limited, it just employs only 1 link. If there's more traffic, it employs both the links. And why the reason for them to do so is they want to probably be a bit easy on the battery. Just use only 1 radio. Why to use both the radios when there's not enough amount of traffic? So just a behavior that I just wanted to demo here. And we also give visibility into the client details, MLO client capability in our 9800 UI as well as in our Meraki dashboard. When you go to our controller 360-degree view, we mentioned that it's an MLO capable client. We give visibility into the MLO and the 9800 controllers as well as in the Meraki dashboard. When you go to the client statistics, they tell you the band to which it's associated and the traffic statistics that it's sending. Meraki has a similar representation. They kind of tell you the different links to which the client is associated. And starting the iOS XE 17.8.1, we're also planning, we'll also be giving insights into the type of MLO method that these clients are doing. It's not available in the current release. 17.8.1 is going to be out in a few weeks from now. So that will have the visibility on the exact MLO method the clients are doing. So this is all going to help you when you do those performance tests in your network. Moving on to the next feature, Wi-Fi 7 preamble puncturing, wherein the access point punctures or carves out a portion of those secondary channel if it's affected by interference. Taking an example of Wi-Fi 6 with an 80 megahertz channel width, if one of those secondary channels is affected by interference, then all the secondary channels gets wasted. None of the secondary channels are used. Only the primary channel alone sends the traffic. With Wi-Fi 7, if one of those secondary channel is affected by interference, then only the 20 megahertz channel alone is carved out or punctured, and the remaining channels are used. You get 60 megahertz of channel width when compared to the 20 megahertz of channel width what you get in Wi-Fi 6. Of course, the puncturing is allowed with a channel width of 80 megahertz or greater. It's not allowed for 40 megahertz channel width. The reason being there's only one secondary channel. If it gets punctured, if it gets infected by affected by interference, it doesn't matter. Here is a demo of how preamble puncturing works. Again, having pointer problem. Okay. Here's a demo that I want to walk through how the preamble puncturing works. We have a Wi-Fi 7 access point, and we have a wireless client that is receiving the traffic from a server, and we have a spectrum analyzer to monitor the spectrum, and we have a Wi-Fi camera as a persistent interference source. So the access point is operating at the UNII-3 channel with the 80 megahertz channel width in the 5 gigahertz band. And initially, to begin with, as you can see in the spectrum, all the 420 megahertz channel is utilized, and the traffic is sent on all the 420 megahertz channels, and the traffic flow is fine. We turn on the camera, and moment the access point detects it's an interference source, it's going to carve out that 120 megahertz of channel. So it's not going to send the traffic, but the remaining 60 megahertz of channel continues to forward the traffic. There's a slight drop in throughput, but it's not a significant drop. And the moment we turn off the camera and the puncturing is removed, and the traffic continues to flow in that 20 megahertz channel. So this preamble puncturing makes use of efficient use of spectrum, and it's really, again, one of the important features with the Wi-Fi 7. Wi-Fi 7 MRU is an enhancement to the existing YFDMA functionality. YFDMA is undoubtedly the most significant feature in Wi-Fi 6. It helps to transmit or receive data to multiple clients simultaneously in a single transmission by sharing the available bandwidth. With the way it does is it groups the subcarriers into smaller units called resource units, and these resource units map to these individual wireless clients. And these resource units kind of carry the data to the wireless clients. In Wi-Fi 6, we had this restriction wherein in a single transmission, only one RU is permitted for one single wireless client. So there could be several resource units that go empty without carrying any data, and some of the clients could be waiting to receive the data, and a lot of spectrum was getting wasted. With Wi-Fi 7, this restriction is removed, wherein multiple RUs is permitted for a single wireless client. So if there is some data to be pending to be transferred to a wireless client, and if there are RUs that are going empty, the access point can very well pack the data in these RUs and send it to the wireless clients. Of course, the multiple RUs make efficient use of spectrum, and of course, is going to improve the latency. The next feature is 512 compressed block hack. In Wi-Fi 6, the number was 256. You can aggregate up to 256 frames before you seek a block hack. In Wi-Fi 7, this aggregation limit is improved to 512 MPDUs before you seek a block hack. Of course, it reduces the protocol overhead and improves the transmitter's performance at high rates. There's a misconception that Wi-Fi 7 supports 16 spatial streams. It's not. The support is maximum of 8 spatial streams per radio. This was one of the initial proposals made to the IEEE committee, but never made it. But if you do a Google search and look for those technical papers, there are pretty much, I would say, about 90% of those technical papers and the blogs, they all talk about 16 spatial streams in Wi-Fi 7. It's not correct. We have only a maximum of 8 spatial streams per radio. An access point as such, with all the radios put together, can have more than 8 spatial streams, but per radio, it's restricted to only 8 spatial streams. Moving on, I want to highlight the availability of clients that is available in the market which can support Wi-Fi 7. And I'm pretty sure you'll agree with me, a rich and stable client ecosystem is absolutely needed for a successful adoption of a Wi-Fi standard, any Wi-Fi standard. So the first in this category is the Android. In fact, Android was the first OS to support Wi-Fi 7. We used all the Samsung S24s and the Google Pixels in the initial days to play around with Wi-Fi 7. And Android has a rich client set and absolutely all good there, no concerns there. The next in this category is iPhone. Apple surprised us all with announcement of Wi-Fi 7 support in their iPhone 16 and 16 Pro models last fall. And in fact, after that announcement, it got the Wi-Fi community excited. There were so many LinkedIn posts and there's extra messages like, where people get their iPhone 16 Pros and started playing around with Wi-Fi 7 and started sharing their observations, really got the market excited. But however, the iPhone 16e that was recently announced in February, they don't have the support for Wi-Fi 7. They seem to have restricted the capability to do Wi-Fi 6, not even 6 gigahertz. The next is an important category, Windows. Wi-Fi 7 personal support is available in the public version of Windows 11 24H2. And the laptops are predominantly based off Intel BE200 chipsets or the Qualcomm chipsets. Of late, we are also seeing MediaTek chipset-based Windows laptops being available there. Wi-Fi 7 Enterprise, the support is not there in the public version of Windows 11. It's available in the dev channels, the Canary builds, and the dev and beta channels. For folks, some of you might have tried out Wi-Fi 7 Enterprise with Windows 11 already, or probably planning to try out. There is an issue wherein Wi-Fi 7 Enterprise clients, they don't roam properly. Either it's a full authentication roam or the roam kind of drops. So Microsoft has fixed this issue very recently. And the build numbers are given in the reference. So if you want to try out in your labs, please to have your Windows 11 with these dev build numbers. The last is, yeah. Yes, the question is, the WPA3 enterprise roaming issue that I mentioned, is it happens only with the Wi-Fi 7 or Wi-Fi 6E? The issue is only with the Wi-Fi 7. Wi-Fi 6E is fine. Moving on, macOS, iPadOS, we don't have the support yet. Hopefully, we'll hear some good news from Apple pretty soon. As you can see, the client ecosystem is still evolving. But we've gotten a lot better when compared to about 6 months back. And I'm pretty sure a few months down the line, we'll have a much richer and broader support. But this is the state of affairs, for you too, because there's an important parameter in this entire the ecosystem. Client plays an important role. And here's a table. We took some of the popular clients out there and listed all the Wi-Fi 7 features, and we tested in our labs as to what works, what doesn't work, the limitations, and so on. And this is just a table for your reference. A couple of things to call out. iPhone still doesn't support 320 megahertz as of yet. And number two, Qualcomm does MLO slightly differently. The Google Pixels does the MLO slightly differently. If the SSID is broadcasted on the 5 gigahertz and the 6 gigahertz band, then they seem to do an EMLSR. And if the SSID is broadcasted in all the 3 bands, they seem to do an MLMR STR with a 2.4 and a 5 or 2.4 and 6. So this is just purely for your reference. Moving on to the third part of my presentation, I want to introduce the Cisco Wi-Fi 7 access point portfolio. But before I do that, I want to take a minute to talk about Cisco's journey towards a unified product. At Cisco, as you may all be aware, we have these two deployment models. One is this on-prem based Catalyst wireless stack. The other one is the cloud-based Meraki wireless stack. Of late, what we are seeing is more and more customers want to migrate from on-prem to cloud because of ease of management, simplicity, and whatever their business decisions. And whenever they migrated, they had to completely rip and replace the hardware. So, and of course, it's a lot of overhead on the customers in terms of time, money, and effort. So we wanted to come up with a common hardware that can work in either of the deployment modes. So we started on this journey with our Wi-Fi 6E. We achieved about 75% on what we wanted to achieve, but with our Wi-Fi 7 access points, we have achieved 100% of the goal what we have set. Yes, we have please don't give me a hard time. Okay, so we now have a common hardware. It's a unified product. It's a single SKU that can work on either of the deployment modes, Meraki or Catalyst 9800 controller. No more this hard coding of this Meraki SKU or hard coding of those country-specific regulatory domains to those access points. Right out of the box, it can join either of the deployment modes, Meraki or Catalyst 9800 controller, based on your intent. And of course, you can also change the management mode at any point of time in its product lifecycle. If you want to, say 1 year down the line, if you want to migrate the mode, you can do so through a simple UI workflow that is present in the 9800 controller or the Meraki dashboard. And of course, we also simplified the licensing as well. It's a unified licensing. We call this access point as the global use AP. You get an access point, you can go deploy them anywhere in the world. Of course, even though it's not a common scenario for someone to procure an AP in US and take them to, say, UK or Australia and go deploy there. But I just want to convey the point. It's one single SKU, but you can deploy anywhere in the world. And when we develop these access points, we don't develop a hardware just to provide Wi-Fi access. We bring in lots of value-added services that makes your access point a truly digital enterprise ready and make your workspace smarter, secure, and assured. With Wi-Fi 7, we now added an inbuilt GPS radio in our high-end access points. We have also added an ultra-wideband radio in our high-end access points. This ultra-wideband radio technology gives us sub-meter accuracy. This UWB radio, along with GPS and Wi-Fi, opens up the possibility of several use cases centered around location aspects. So use cases like this AP Autolocate, AFC is something that you can already consume. We're also working on enhancing the indoor navigation and asset tracking, and we're working again with popular client vendors out there to get that the accuracy. And we're also working a lot more use cases employing these radios. And these high-end access points also have an accelerometer built in to know the kind of tilt position, the direction and so on. So you need not visit each of the, the access points, look at them if it's properly installed. You can sit in front of your controller UI or Meraki dashboard to know if this access point is properly mounted. Of course, we continue to retain many of the good functionality that what we have already in terms of dedicated AML-powered scanning radio, and then FRA capability, BLE radio, like container hosting capabilities and smart power consumptions and dual Ethernet ports on our high-end access points. They all continue to be there in the access points. Right now, we have 5 shipping Wi-Fi 7 access points. The very high end, our 19178. It's a quad radio, 16 spatial streams, and it has dual 10 gigabit Ethernet port. One step down the line, our 9176 series, there are 2 variants there. The 9176i has an omnidirectional antenna, ceiling mounted, that gives a 360-degree coverage. 9176D1 has an integrated directional antenna, especially it finds its place in use cases like retail, then auditorium, long hallways, where you want to have a directional coverage, where you want to focus the RF energy. Recently, we started shipping the low-end models, the 9172. There are 2 variants there. The 9172i is ceiling mount. that gives a 360-degree coverage, and the 9172H, it's a wall plate form factor that finds its place in hospitality industry and, of course, the university dorms. It has 3 built-in LAN ports, and one of the port can be a PoE out. And at this Cisco Live, we are launching industry's first Wi-Fi 7 access point for large venues and stadiums. It's again a quad radio, 16 spatial streams. It has 2 10 gig Ethernet port, and there's a lot of cool features. It has this outdoor and indoor flexibility. It's the same hardware that you can use indoor or outdoor. Just you need to add an environmental pack that makes this product ready for an outdoor deployment. It also has this unique front and back concept where the front is an integrated antenna, and it kind of gives directional coverage. And when it gives this directional coverage, sometimes right below the access point, behind the access point, we don't get the coverage. So it has the flexibility where you can attach an external antenna, and you can get coverage right below the access point or behind the access points. And of course, it also has this software controllable beam switching. You can switch the antenna patterns here. I don't want to steal the thunder here. This product is actually going to be announced tomorrow, but when you go to World of Solutions, please do take a look at this product in the product wall. And yes, sir. 8 spatial streams per radio. Per radio, 6 gigahertz, like 5 gigahertz, that's 8 spatial streams, right? Then your 6 gigahertz, another 4 spatial streams. Your 2.4 is another 4. If you add all of them, you get 16 spatial streams. But one single radio cannot exceed 8 spatial streams, okay? And there is a dedicated session by my colleagues, Matt Swartz and Josh Swartz. The session ID is given there. It's on Tuesday, 2 p.m. Please do attend their session if time permits. That is good. They're going to talk about in detail about these access points. I mentioned about the global use AP, where the access point can connect to either of the deployment modes based on your intent. So how do you make the AP connect to a Meraki cloud or the Catalyst 98 controller? What are the prerequisites? Number 1, if you want your access points to connect to the Meraki cloud, make sure there is an internet connection that is present from the AP subnet, and it can reach the Meraki dashboard, and these APs are also claimed in the Meraki dashboard. If you want to connect to a 9800 controller, continue to use those traditional discovery mechanisms like this DHCP options, option 43 and the DNS, and then the PNP server. So here is a map of the global uses AP's journey. So the green circle indicates an AP fresh out of the box, and red circle indicates an AP that's factory reset. It's pretty much like fresh out of the box. And once you power up, it's just going to boot up and gets its IP address and all those DHCP options and DNS. And at this point in time, the firmware has to make a decision whether it has to go to the Meraki or the Catalyst. If there is an internet connection, and if it's getting a response back from the Meraki cloud, it's going to go join the Meraki cloud. If not, it's going to wait 8 minutes to avoid any race conditions. And after 8 minutes, it's going to make use of those DHCP options and the DNS options to join the 9800 controller. Of course, you can bypass this 8 minutes by using what is called a fast offline migration. It's a new DHCP option and the DNS option that we have provided. So if you configure them, you can completely bypass this 8 minutes. And once this once this access points joins the wireless LAN controller or the Meraki cloud, the normal operation resumes, the day 1 operation continues. But for the APs that has joined the wireless LAN controller though, it has to resolve the country code. Remember, these access points do not have the hard-coded country-specific regulatory domain in the access points anymore. So it has to know a way in which country these access points are operating. So there are 4 methods in which it can resolve the country code. So I'll walk you through that in a minute. So normal operation continues, and at any given point of time, if you want to change the management mode, you can do so through a simple UI workflow. And if you want to factory reset, the factory reset sequence is exactly same. That will bring you back to the day zero mode, and you can start all over. So how does the AP that is in the WLC mode gets its country code? The first is through the inbuilt GPS and GNS. Once it gets the latitude and longitude, it presents its country code to the controller. And other method is called what we call as the proximity. It learns its country code from the nearby access points. So the access points could be a legacy access point that's connected to the same controller, or it could be the access point that kind of resolved its country code through the GPS or GNSS. When the AP access point joins the WLC, only the 2.4 gigahertz radio is on. The 5 gigahertz and 6 gigahertz radio has to be shut off due to regulations, and it uses the 2.4 gigahertz radio to listen to the NDP packets. Through the NDP packet, it learns the country code and presents the country code to the controller, and as long as it matches, the AP is going to enable all its radios. And the third way is, right on day zero, you can take these access points to the Meraki cloud. Give them a one-time internet access, make them to join them the Meraki cloud. From the Meraki cloud, you can convert all these access points to a 9800 or WLC mode. When you convert these access points, the country code is retained in its memory, and you don't need to resolve the country code. The last one is for the air-gapped customers, where they are in a location where the access points cannot see the satellites, or they don't have any legacy access points, or it doesn't have any internet access. How do we go about there? Through a method called regulatory activation file. So you download this regulatory activation file from the Meraki dashboard. So you need not make the APs join the Meraki dashboard. It's just a matter of you key in the order ID, claim those APs, assign them to a network, and download this regulatory activation file. It's a JSON file. It contains the serial number of the access points and the country and etc. And you can install this file in the wireless LAN controller. And when this AP joins the wireless LAN controller, it's going to get its country code. So all these steps are it's captured in detail in a global use AP deployment guide. The link is provided there. So please do go through this deployment guide if you're planning to install these access points in your network. For Meraki customers, the experience is going to be exactly same. For wireless LAN controller customers, you just need to be aware, if you're using an existing options, you need to wait for 8 minutes. If you don't want 8 minutes, then you need to use this fast offline migration. And number two, that you need to resolve the country code. And we talked about the different methods in which the AP resolves the country code. The question is, if I use the regulatory activation file, initially I downloaded this regulatory activation from Meraki, added 50 access points, and later on I plan to add this 50 more access points. Do I need to download the regulatory activation file again? If they are brand new 50 APs that you're placing a fresh order and you're getting them, then you need to claim and then install the file again. If it's something, it's already part of the first order, and it's just that you're delaying the installation, you can do so without installing the file. Moving on to the network infrastructure, we strongly recommend mGig switch port as the effective throughput clearly exceeds way past the 1 gig. And Wi-Fi 6E, this applies to both the Wi-Fi 6E and 7 access points. For cabling, we recommend Cat 6 or 6A, as it can drive speeds up to 10 gigabits. Cat 5e can also do speeds up to 5 gigabits. Again, here's a performance test that we did, taking our 9176 access points, trying out with these different switches with a gigabit port and the mGig switch, and you can clearly see that the throughput is 5x when the 9176 access point is connected to a 10 gig port when compared to a 1 gig port. So it is with both TCP and UDP, and we tried out different scenarios with 3 clients and 10 clients. Yes, sir. My sincere recommendation, the question is, hey, you're saying the effective throughput is going to be more than 1 gig, so is your recommendation to have a 10 gig port? For this high-end access points, which has 10 gig Ethernet ports, The recommendation is to have a 10 gig, of course, switching port, but understand that it's not possible to just overnight go with a 10 gig port. Even if you have the 5 gig or 2.5 gig mgig switch ports, you're going to see a marked improved throughput improvements. So 9178 needs a special mention. It has two 10 gig Ethernet ports for PoE and link redundancy. Okay, so the effective throughput is still going to be 10 gig or less. It's just not going to aggregate. You're not going to get more than 10 gigs of throughput. And of course, these APIs can be configured on the lag or the non-lag mode. Non-lag mode is the default. And in non-lag mode, we support both single and dual home connection. Some customers want to run the cable to two different IDF rooms, connect to two different switches for redundancy. In the lag mode, though, we support only single home, be it virtual or physical switches. Power considerations, an important topic. AP negotiates its power during boot time through CDP and LLDP. And when it negotiates for the maximum power that it needs to operate. And this is the power allocation, and this is the number that you need to consider for your power budget. But the actual power consumption could be way less than what it has requested. It depends on many factors like the number of radios it has turned on, the Ethernet speed, the number of clients it's serving, the amount of traffic that it's pushing, and it can vary. So a recap of power over Ethernet standards. You need to be aware that most of these Wi-Fi 7 access points needs IEEE 802.3 BT power for it to operate. 802.3 BT power is a very generic term. There are multiple classes there, starting all the way from class 5 to class 8. That's 45 watts to 90 watts. So the devil is in the detail. So for our 9178 access point, for its full operation, including the USB, it needs the class 6 BT power, which is 60 watts. Whereas our 9176i and D1, for its full operation, including the USB, you need class 5, which is 45 watts of power. The 9172i, which is our low-end model, if you want to use the USB port, if you want to plug in for some additional functionality, then you need a class 5 BT power. Otherwise, you can operate that access point just with an AT power. Same goes with the 9172H. For full radio operation, AT power is good enough, 30 watts is good enough. But if you want to configure the LAN port to give the PoE out, then you need the class 5 for its operation. Moving on, an important topic, WLAN security. And why is an important topic? Because Wi-Fi 7 has up-leveled the security requirements to WPA3 to be minimal and mandatory, that is needed for certification and also for operation. There's a new AKM support that is needed for WPA3 personnel. There are also enhanced ciphers requirement, GCMP 256 pretty much for all the security methods. PMF is mandatory, and beacon protection is mandatory as well as for Wi-Fi 7. So WPA3 is not something new. It's been there for a while now. It's included in the Wi-Fi 6 certification days right from 2018. So the key difference in terms of requirements for Wi-Fi 7 when compared to the early generations is with Wi-Fi 6, it was not made mandatory, but all the clients were supposed to get certified for WPA3. And the difference between the Wi-Fi 6E and Wi-Fi 7 is you have this new ciphers, GCMP 256 in addition to the AES, and also there is this new AKM added for personnel. That is SAE extension key or FT SAE extension key that translates to AKM 24 and 25. That's absolutely needed for Wi-Fi 7 operation. For WPA3 Enterprise, the same goes. The only addition is the GCMP 256, but all our implementation today, it's all only with AES. GCMP 256 is something going to come in the future. The other feature is the beacon protection. The beacons are protected with an integrity check to make your networks more secure. So the way it works is when the client associates during its 4-way key handshake, in the M3 message, there's a beacon integrity key that is transferred to the client, and client uses this integrity key to validate this message integrity check if the beacon is coming from a legitimate AP or from a rogue AP. If it's a legitimate AP, process the beacons. If it's coming from a rogue AP, drop the beacon packets. So, one other thing is in the early days, it was a very relaxed implementation from the client side. The clients were not following the specs. They were using the AKMs they're not supposed to do for Wi-Fi 7. And on the access point side, we were relaxed as well. So because we want to allow all client types to join, we don't want to exclude certain client types. So you will see a relaxed implementation on the earlier code. But going forward, we're going to get stricter to the dot what the technical spec says in terms of implementing the ciphers and the AKMs, otherwise you don't get the functionality. So with this new security requirements, what are all the WLAN design options that we have? So number one, what we call is an all-in option, wherein you reconfigure all your existing SSIDs to be a pure WPA3 and OWE. So this way you're going to make your network very secure, and you're taking the very bold step of making your network secure. But is this a likely option? Probably unlikely, because there could be still clients that's present out there that cannot do WPA3 and they can get stranded. So take this, use this option only if you're pretty sure that all the clients in your network is capable of doing WPA3. Number two, what we call as a multiple SSID option, wherein you leave all your existing SSIDs as such, you create a new WLANs just to take care of the newer clients like the Wi-Fi 6E and Wi-Fi 7 clients. This way, you're taking care of your existing clients, and this newer WLANs can take care of the newer capable clients. So the only downside is you have to maintain multiple WLANs, both on the infrastructure side as well as on the client side, multiple client profiles. The third one is what we call as a one SSID option, wherein some customers are very particular. They want one SSID, but take care of the lower security as well as the higher security. A classic example would be this EduRoam SSID in these universities. And some of the popular retail stores also, they want to have the same SSID name. So, but take care of all different security types. Is this possible? Yes, absolutely it's possible, both in our controller as well as in the Meraki dashboard. We use these transition methods to support these different security types, and we will see how we do this in a minute. And one other question that I get, it's an innocent question that I get, is that, hey, with all this new security requirements with WPA3, can these Wi-Fi 7 APs broadcast SSIDs with a lower security? Yes, absolutely, it can broadcast SSIDs with a lower security. The only thing is, the clients are going to lose the Wi-Fi 7 functionality. They are not going to get the 11BE rates, they are not going to get this MLO functionality, and they also cannot join the 6 GHz band. So this is something you need to be aware of. So option 1 and 2 are very straightforward. It's just about reconfiguring the SSIDs. But what about option 3, one SSID? How do you go about it? I'm taking the... Yes. No. And it's automatic. So the beacon protection is after the first client association, it's after the first client association, and you need not do anything on the client side to have this beacon protection. WLAN design considerations, option 3, I've taken an example of WPA3 personal here, and a screenshot from a 9800 controller. The way you go about in the security requirements, you select WPA2 plus WPA3, which we call as the transition mode or the mixed mode. You select all the ciphers that is needed, that is CCMP 128 and GCMP 256, and the AKMs that is needed, PSK, SAE, and SAE extension key. If you want to have fast transition, then enable the fast transition and select the FTPSK, then FTSAE, and then FTSAE extension key. So this is like the golden configuration. You are pretty much taking care of all the clients, be it WPA2 clients or WPA3 clients. And within WPA3, Wi-Fi 6E needs SAE, Wi-Fi 7 needs SAE extension key. Pretty much this configuration kind of takes care of all the clients. This configuration cannot take care of the clients which still does the old WPA. If you still have clients that does the whole WPA, then the recommendation is you create a separate SSID to take care of those clients. Otherwise, this configuration all the way from WPA to Wi-Fi 7 clients is the golden configuration. Very similar flow for the enterprise as well. You select WPA2 plus WPA3 and the AKM as CCMP 128. This is a CCMP 128 requirement is as of now. As the clients evolve and we also going to get stricter, you have to enable GCMP 256 as well. Select the AKMs as .1x and .1x SHA-256, make the PMFS optional, and you're good to go all the way from Wi-Fi 6 clients to Wi-Fi 7 clients. So I talked about WPA3 personal, then I talked about WPA3 enterprise, but what about open? So there is a OWE transition that is present out there. So what do we do there? So as per the WPA3 specs, OWE transition is not supported in the 6 GHz band and in Wi-Fi 7. You need to have a pure OWE WLAN if you want to have any of those guest networks operating in the 6 GHz band or the Wi-Fi 7 capability. So today we allow the configuration in 98 controller to give the flexibility, but going forward we will get a bit stricter. OWE transition will still work, but it will work only on the 2.4 and the 5 GHz bands. So if you want to have any guest network, make sure you have a pure OWE only WLAN. And we also seen most of the clients do not move to 6 GHz. Even though they connect to the OWE transition, they always get stuck with this 2.4 or 5. Some clients, very, very few clients seem to move to the 6 GHz band, but they will also change their, the algorithm to restrict only to 2.4 and 5. Here is some of the client join behavior, simple scenarios. What if you have a network that it's broadcasting only a WP8 or open WLANs, and at the same time you want to migrate a portion of your network to Wi-Fi 7 because it's your refresh cycle. So what's going to happen? All the clients are going to join, no problem, but only thing is the Wi-Fi 7 clients are going to operate with the lower capability as 11AX, and you're not going to join the 6 GHz band. Oh my gosh, again. What if you're broadcasting the WPA3 transition WLANs? Just make sure to enable the proper ciphers and the AKMs to allow those Wi-Fi 7 clients. Again, as I mentioned, this is the golden configuration that you can take care of all the way from your Wi-Fi 5, which is going to do the WPA2, to the Wi-Fi 7 clients, which is super strict on the security requirements. The third one is, if you have taken the move already and have some of the WLANs doing a pure WPA3, well and good. The only downside is the older clients will not be able to join this new WLAN. I talked about the client join behavior, but what about the client roam? If I have a Wi-Fi 7 client, can I seamlessly roam to a Wi-Fi 6 or a Wi-Fi 6E AP, because the security requirements is way high in the Wi-Fi 7 when compared to the Wi-Fi 6 and Wi-Fi 6E. So let's take an example. I have a Wi-Fi 7 AP and the WLAN profile, for reasons I've just restricted to SAE extension key, which is the requirement for Wi-Fi 7. And here's a Wi-Fi 7 client that joins with this AKM and cipher as GCMP 256. And when you roam to a Wi-Fi 6E, so what we have done is, we have backported all these AKM, newer AKMs to our existing access points, like the Wi-Fi 6 and the Wi-Fi 6E access points. And most of our existing access points can also support this new cipher, that's the GCMP 256. So when this Wi-Fi 7 client roams to the Wi-Fi 6E AP, because it can support the newer AKM, it can have a seamless roam, and of course the client will join the 6 GHz preferably. It can also roam to a Wi-Fi 6 AP. So that supports the GCMP 256. For example, our access point like 9130, 9124, they all can do GCMP 256, and it's going to be a seamless roam. But some of our Wi-Fi 6 access points like those 9120 and 9115, they do not support GCMP 256. So what happens there? So the wireless client, the Wi-Fi 7 client, if it initially joined with GCMP 256 as the cipher, when it roams to such Wi-Fi 6 AP, because of the mismatch in the cipher, it's not going to be a seamless roam. It's going to disconnect and rejoin. If the Wi-Fi 7 client initially joined with AES as the cipher, then it can have a seamless roam to the Wi-Fi 6 access point. We have done a lot of tests in our labs, making the client move from Wi-Fi 7 AP to Wi-Fi 6 AP and back and so on. So it does a seamless roam as long as the AKM and the ciphers match. So we're given the flexibility to have these new AKMs and ciphers in most of our existing access points as well. The MAC address is something I've highlighted just to indicate the fact that the very first roam, very first one is with the Wi-Fi 7 client. It uses the MLD upper MAC layer, and it roams to a Wi-Fi 6 AP, it uses the lower MAC layer. So when it roams back to the Wi-Fi 7, it uses the upper MAC layer. So you just need to know which MAC address to look for. A very similar workflow with the client roam behavior with the OWE as well. As long as the ciphers and AKMs match, it's going to be a seamless roam. With the enterprise, it's all going to be a seamless roam all the way to the Wi-Fi 6 APs because we have not enforced the GCMP 256. Going forward, pretty soon, we will enforce the GCMP 256. As and when we test more clients in our labs and see how they behave, once we understand the behavior, and we also inform our client vendor partners, then we'll make the decision to switch over to the GCMP 256. Here are some slides that gives all the different security combinations and what's compatible and what's not compatible, what works and so on. So just purely for your reference, this slide is for enterprise, and this slide is for personal and enhanced open. And this can be very, very handy if you try out Wi-Fi 7 in your lab. And again, there's another reference slide where I've given the Wi-Fi 7 client WPA3 support matrix. So as you can see, FT methods are not supported in those Windows laptops yet. So it's still not supported. And similarly, the Google Pixels also, they don't do the FT anymore. I mean, not anymore, but just that they don't support with the Wi-Fi 7 yet. They are supposed to, I mean, they will implement pretty soon there. MediaTek, similarly, doesn't support those FT implementations yet. Moving on to the last but one topic on the RF design, one of the questions that I get asked is, hey, do I need to do a site survey again whenever there is a change in the generation of Wi-Fi? And coincidentally, I got this question as recent as last Friday from one of the customers who was doing a refresh, who is migrating from Wi-Fi 5 APs, and they placed an order for Wi-Fi 7 APs. So there are certain design considerations that you need to keep in mind. Remember, that's altogether a new 6 GHz band it's available now. So you need to consider designing the 6 GHz band, right, for coverage and capacity and so on. And also within the 6 GHz band, we have the 320 MHz channel width. And so you may want to have a floor plan with some of those access points operating in this 320 MHz channel width. And with the multi-link operations, you want to ensure that you have a uniform cell size, especially between the 5 GHz and the 6 GHz for the optimal use of both the bands. And the last time when you had done the survey, probably it was many years back, and you had done the survey just for coverage, and things have changed a lot now. So the client density have gone up, and each one of us has multiple gadgets now. And the applications are very different now, like when compared to the applications what we used to run 4 or 5 years back. And if it's, when we try develop our access points, we ensure the antenna gain and the antenna patterns are all very, very similar. But there is a chance that with a very old generation of access points, the gain and the antenna patterns could be very, very different. And also there are some regulatory changes that happen where they bumped up the transmit power in some of those 5 GHz bands. So these are all the different parameters that you need to consider for your RF design. And in my opinion, if you ask my recommendation, if you're running a very old network, like say Wi-Fi 5 or Wi-Fi 4 network, the recommendation is do a site survey again to accommodate Wi-Fi 7. But if you've done very recently, with the Wi-Fi 6E and so on, and you should be okay, pretty much both from the hardware aspects of it and from a 6 GHz band and the client applications as well. So RF design is a very deep topic, and I cannot do justice in this just 15-20 minutes. It needs a dedicated session as such. And pleased to join this session by my colleague, Mr. Jim Florbeck, who is an RF expert, and he will cover the RF design aspects of it, and if you want to know more about the RF design. So when you want to migrate, the very first thing is that you need to know the software where these access points are supported. For the Wi-Fi 7 access points, the support starts from the 1715X iOS XE train. So there are chances you might be running 1712 or 17.9, the Gold Star versions, and at the same time you want to adopt Wi-Fi 7 in your network. So we'll discuss how do we go about it. And then secondly, on the Meraki, Wi-Fi 7 APs are supported from 31.1x release. And if you are already in the 9800 journey, and if you have your controllers that's running the earlier releases, 1712 or 17.9, at the same time, you want to adopt Wi-Fi 7 in portions of your network, the only recommendation is get a 9800 controller that runs this 17.5 or 17.7 iOS XE version, park your Wi-Fi 7 APs and the Wi-Fi 6E APs there, form a mobility group, but is the seamless roam going to work for all the client types? The seamless roam can work as long as the AKMs and the ciphers match. In your existing network, you might have Wave 1 APs that does not support WPA3. You cannot have a seamless roam there. What if you have an Airvoice network? I was having a conversation prior to this beginning of the session, and this gentleman had just removed, kind of got rid of the Airvoice controllers. So I got to know that several of you probably are running still the Airvoice controllers, because that's working great. And if you want to adopt Wi-Fi 7 in portions of your network, get a 9800 controller, run the required software versions, park your Wi-Fi 7 6E APs there, form a mobility group, and seamless roam, as far as the seamless roam is concerned, it's going to work for the WPA2 clients, definitely not for the WPA3 clients, because there are chances you might be having those very old access points connected to those controller. So moving to the last section in summary, if I were to recap, what are the key parameters that you need to consider for deploying and migrating to Wi-Fi 7? The very first one is the power considerations. Please note that most of these access points need a 802.3 BT power. The devil is in the detail. Look at the class, what class of power that it needs. And the second consideration requirement is we recommend mGig switching infrastructure. And the third one is security requirements. Pay attention to the security requirements, the AKMs and the ciphers, and how to go about designing your network, where you can coexisting your existing WLANs as well as the newer WLANs, and also take care of your existing clients as well. And the last one, we talked about the wireless coverage. So my recommendation is if you're running a very old generation of Wi-Fi, please do a site survey to accommodate the 6 gigahertz and some of the other requirements. Yes, sir. I would say I need to get back to you on the specifics, but our interop team pretty much test all the cabling standards that's available out there. To your specific question on this particular category of cable, I need to get back to you. I don't have an answer on top of my mind. But in general, we do test all the cables out there. Yeah. And the last slide, I use this slide to kind of describe any adoption of any Wi-Fi standard using this crossing the chasm. If you look at a year back, the consumer Wi-Fi market just started to take off because the certification just got ready in January. Enterprise was still very experimental stages, but 1 year later, the consumer market has picked up very well. But for the enterprise, what we see is lots of early, testing, lab trials, and proof of concepts, and some customers have enabled Wi-Fi 7 in some portions of the network. And with that, thank you, thanks a lot.